10 common mistakes people do when they set up and calibrate subwoofers. The first one is doing no calibration at all. You have no DSP, you have no time alignment. Can it still work? Sort of. That depends on the system, on the room placement. But if there is no sort of signal processing, there has to be some sort of a crossover, there has to be some sort of control of time alignment and so on. If it isn't, it will not work well. Number 2, focus on frequency response alone. That is very usual. You see, they have set up the REW measurement, and they have a microphone, and then they have the frequency response. And then have to use a magnifier and zoom in to see all the wriggles. This doesn't work. We need to look at resonances and time domain. That is where the secrets to good sound lies. Number 3, view frequency response only below 200 Hz. This is a common mistake. The zoom in the frequency response, so the whole range they see on the screen is just a part that they think is interesting, because that is the part that we're supposed to calibrate when we calibrate subwoofers. It's below 200 Hz. But when we don't see the rest of the frequency response, the graph that goes upwards, then we have no context. We don't see the level, we don't see the deviations and so on, and the tilt of the curve in relation to the whole frequency range. And we need the whole frequency range to see that complete picture of the sound. Number 4, no time alignment between subwoofers and main speakers. This is common when main speakers are run directly with no filter, no processing. There may be an analog filter on the main speakers, but if you don't have a digital processor on the main speakers, there is no possibility to add the proper delay on the main speakers, and then it is impossible to get proper time alignment. Number 5 is trying to boost the dips. As we saw in subwoofer calibration videos, we had a very deep hole, and we could also hear this hole when we compared the music samples from this system. We compare them, and if we listened on the reference system, the large system with 4 subwoofers, where we can fill in this hole, then there was a clear and very audible difference. So it makes the difference. But we can't boost those dips in DSP, because those dips are cancellations due to reflections in the room, and trying to boost this dip and push energy into a cancellation only wastes the energy, and we are never able to boost and get the level in this dip up. 6, trying to equalize the frequency response to completely flat, thinking that it has to look perfectly smooth and flat to sound nice. That is wrong. As I mentioned earlier here, we need to focus on what happens in the time domain, because that is where the faults are. And also we may not desire to have a flat frequency response. Perhaps we want our special taste. We want to add some flavor to the bass, and then it will not look completely flat anymore. We use this, we boost and lower different parts of the frequency response in the bass range, and we do this to accommodate a special preference or taste or sound character that we want to achieve. but also to compensate for other deviations in the system response that occurs inside the room. This may be related to tactile response, tactile feel. It may be related to where in the room we are measuring compared to where we sit. My body here now has a different response lower down in my body compared to where my head sits up here. And number 7 is failing to assess sound field properties that relates to the energy of the sound field. When you set up systems with typically with 4 or more subwoofers, where the subwoofers are placed both up front by the main speakers and at the rear back in the room. Because if those front and main units are not properly time aligned, they will create a cancellation of the velocity potential in the sound waves. And this will lead to us measuring the pressure with our measurement microphone. It measures completely flat, but if we set up a velocity microphone or a directional device or something that measures the sound energy or the sound velocity potential, then we will measure that we may have 0 velocity, and this is experienced very, very strange, and we lose lots of what is this powerful and airy feel of the bass, especially at the lower frequencies from 40 Hz and downwards. Number 8 is no high-pass filter on the main speakers, thinking that our main speaker, it rolls off, and if it doesn't, it blends in with the subwoofers. So this, yes, it's great, lots of pass. That's a very, very bad idea, because one of the main advantages of having a subwoofer system is that we now are able to remove the strain of reproducing the bass from the main speakers, and this leads to huge improvement in lower mid-range and mid-range reproduction from the main speakers. We increase the capacity by huge amounts, multiples, and we lower the distortion. We gain increased clarity, increased dynamics. You will see a graph of a typical main speaker. This one rolls off, you see, below 30 Hz, but there's a big hole and then there's a big resonance. If we let this speaker play all the way down, this resonance right around 40 Hz is still present. If we calibrate the subwoofers so they are perfect, that doesn't help, because the main speakers are still playing along and destroying everything. Number 9 is too low crossover frequency. Often you see recommended and used 40 Hz, 60 Hz, very common, and 80 Hz is then kind of maximum upper limit recommended. My subwoofers are all made and recommended for 120 Hz crossover, and there is a reason for that. If you have a system where the subwoofers are placed back into the room, or you have back units placed at the back, at the rear wall, then those subwoofers usually need a lower crossover than 120. You may have to go down to around 80, because if you don't, you will be able to hear those subwoofers. And finally, number 10 is not doing a proper listening when we do this. We can't just measure and then see a nice flat frequency response, and then think, yes, we are done. And you may also then have found that, oh, there is something called time alignment. I need to do that as well. Then you do that, you do that so that the time alignment is correct. You get a flat group delay, and then you get the phase response. I don't get that one flat. That is correct. It is very, very difficult to get a flat phase response down in the bus range. But you need to be able to get a reasonably flat response from around 60 up to 120, 150. That's the most important range, because you have this schmack. And to get this schmack, we need time alignment and proper phase response. So you need to get that, and you see on the graphs, and you are happy because flat group delay, flat phase in the right range, and you have the summation of the frequency response. You have the low section, the subwoofers, they roll off like this upwards, and the main speakers roll off like this downwards, and then everything sums, and there is no hole or cancellation where they add up. So yes, this looks great. And the frequency response is, yes, this looks great. You have to listen to this. The first to listen to is, of course, the overall bass level. Is it correct? We also often prepare to make several presets. Depends on the DSP, what possibilities you have to make that. To have different presets, because perhaps we play very low volume late in the night, like now. So then we have a preset with the increased bass volume, but when you turn up the volume, it gets too loud. Can't have it like that. Also different bass volumes for different recordings and styles of recordings. Down back in the 80s, many recordings sounded very thin in the bass range. And then modern recordings nowadays, they are very heavy. Think Billie Eilish, for instance, very heavy in the bass. So we need to do a proper listening and adjust according to what we hear, because our goal, the purpose, is not to make nice measurements, it is to make nice sound. And we have to adjust our reference on the measurement chart according to what we hear to get good sound. So that was my 10 points for common failures for doing subwoofer setup and subwoofer calibration.